Hi guys, this is the inverse functions 2.7. Okay, this is the last section of this unit 2 transformations of functions. So if you take a look at the inverse functions, it's not that you are taking the inverse of numbers actually, you're taking the inverse of the whole function. So what it means by inverse is that inverse functions undo each other, meaning remember the x is the input, y is the output. Whenever you plug numbers into the x, whatever the result from that is your y. Now you're doing the reverse process of it, okay? So that's what I mean by undo each other. Now the inverse of f at x is called f inverse, but in terms of the math notation, you have f negative 1. Now this negative 1 is not an exponent, it's just a way of saying it's the inverse function. Okay, just be really careful with it. It's not the exponent of negative 1. And then in the inverse function, from the original to the inverse function, your input of the original actually becomes the output, because as I said, we're now going backwards, right? We're now going backwards. So because of that, the domain of the original now becomes the range of the inverse. And same thing goes, the output of the inverse is the input of, so output of the original is the input of the inverse. And because of that, the range of the original now becomes the domain of the inverse. So it's easier for you to find the domain and the range of the original, and then just to switch them so that they become the range and the domain of the inverse. Now, one last important characteristics of it is that f inverse is a reflection of the f at x in the line y equals x. Okay, now then you will think, but isn't it sometimes tricky to draw it? Well, all you have to do is use the order pairs on the original graph and then use them to graph it. I will show you how to do that in a bit. Okay, now if you look at the order pair of the original and the inverse, those two are the reverse order. So if you look at the original function, let's say it is fx comma y, so it is x comma y, and then that becomes y comma x. Okay, so they basically switch the placement, not the sign or number or anything else. It's just they switch the placement. Okay, so let's take a look at a couple of examples here. So if you look at it, it says find the order pair of inverse function. So let's say 1 comma 2 is the point of on the original function. Now if I'm looking at that point and want to find out how that one becomes when it is on the inverse, it basically becomes 2 comma 1 by switching the order of it. Okay, now same thing goes for the negative 4 comma 2, so that becomes 2 comma negative 4, and then the negative 10 comma negative 20 becomes negative 20 comma negative 10. Okay, so you just basically switch the order of it to find the order pair of the inverse. Okay, now then the next one is in terms of the equations. So sometimes there is an equation for the original function, and then you need to convert that into a inverse function. So in order for you to do that, the very first thing is to switch x and y. Now sometimes y is in the form of f at x or g at x or whichever the thing. Okay, and then switch x and y and then isolate y. So if you take a look at the first example, you switch this y with this x, so that becomes x equals 3y minus 4. Then your job is to isolate the y again, so this becomes then x plus 3, sorry, not x plus 3, x plus 4 equals y, 3y. So x plus 4 divided by or over 3 equals your y. So your inverse is now this one. Okay, now then let's take a look at the second one. So the first one was linear, so it was okay. The second one is the quadratics. It's a little more complicated, meaning there's one more step to it, but it's okay. Just be really careful with one thing. I'm going to actually point out to that one a bit later. So I switch it, so x equals then 3y squared plus 4. Now in order for you to isolate the y, I have to get rid of the plus 4 first, so that becomes x minus 4 and then 3y squared. And after that, I have to divide everything by 3, so x minus 4 over 3 equals y squared. Now then, in order for you to get rid of the square, we have to take a square root of it. So your y equals then square root of x minus 4 over 3. Now something that you have to be very careful of is that when you take a square root of something, you have to take the plus minus for that one. Okay, so your inverse is your inverse of y equals 3x squared plus 4 is plus minus square root of x minus 4 over 3. Okay, now then let's take a look at the last one. So we have y equals square root of x minus 4 plus 2. So this becomes then x equals square root of y minus 4 plus 2. So x minus 2 equals y minus 4 and then square root of that. And to get rid of the square root sign, you have to square that. So x minus 2 squared equals then y minus 4. So then your y equals x minus 2 squared plus 4. So the inverse of the radical, you have to be very careful of it, because in terms of the graphing wise, your radical function looks like this. Now when you try to draw the inverse function, which we just found here, then it actually looks like that. But as you can see, the blue one, which is the original, only has 1/2 of it, right? Whereas the quadratic has two pieces, right? One piece right there and another piece right there. So you have to be very careful of it. Now, how do I then determine which piece belongs to our original radical function? Well, if you look at it, we have plus, right? That's one way. So our parabola has to be just the right side half of it, okay, which represents the plus part of the x value. Another way of saying is that, hopefully remember that it's a reflection along the y equals x. So if you look at this green piece where this blue piece, they actually look like there is a reflection on the y equals x line. But if you look at, let's say, this half instead of this half, then it's not really a reflection on the y equals x, right? So that's how we can figure out. So when you try to deal with the equation of an inverse of a radical function, you always have to put the restriction, okay? So saying x has to be greater than or equal to 2, okay? So this way it is restricting that it's only the right side, okay? Now, how do I know the 2? Well, this is basically your x value of the vertex, right? Vertex x value. So from the vertex value, right? From the vertex value, it's either this side or that side, and this happened to be 2, and has to be this side. So that's why x has to be greater than or equal to 2. Okay. Now then it says find the domain and the range of it. Well, the first one, so the first example, has the domain of x as an element of real number, right? X such that x is an element of real number, and the range is also y such that y is an element of real number. Now, as I said, the inverse and the original, they switch the x and y in the order pairs, so their range and domain also switches as well. Therefore, for the inverse, the range, the domain of the original becomes the range, and then the range of the original becomes the domain of the inverse. Okay, so as long as you remember that, finding domain and range should be quite simple and easy. Now then, let's take a look at the next one. We have y equals 3x squared plus 4. So this one has a domain of everything, x as such that x is an element of real number, because it is a parabola, right, looking like this. However, the range is then y such that y is an element of real number, but there's a restriction because the graph is going upwards from the vertex of 0, 4. So y has to be greater than or equal to 4. Okay. Now, then the domain and the range switches. So the range now of the inverse is then y such that y is an element of real number. Okay, and then the domain of it then becomes x such that x is an element of real number, but x has to be greater than or equal to 4. Okay. Now then the last one is the tricky one, right? I'm just going to draw a line so that we have enough space. Okay, so this one, the domain was that x, I'm going to cut the thing x such that x is an element of real number, but the restriction of that is that x has to be greater than or equal to 4. And that's because our radical cannot have negative number inside in a real number zone, so x has to be greater than or equal to 4, so that inside of the square root sign becomes either 0 or in a positive number, okay? Now the range then has to be y such that y is an element of real number, and then y is greater than or equal to 2. Now the reason is very simple, because the radical sign, the square root of x minus 4 part, cannot be negative or, cannot be negative, right? So it can only be 0 and up. Therefore, the smallest possible number the y can be is 2 because of the 0 plus 2. And then after that, the radical part becomes bigger and bigger, so your y value becomes bigger and bigger. That's why your range has to be greater than or equal to 2 as the restriction. Now, then the range and the domain changes. Now, this is a special case, so I told you that you have to be careful with it, right? So your range now is a part of the real number, and then your y value is greater than or equal to 4. Now then your domain is x such that x is a part of real number, and then x is greater than or equal to 2, as I said it before when you were changing the equation of the radical, okay? Now then let's go to the next page, and the next page is all about how to graph, okay? We can finish this in about 5 minutes. So bear with me. Now, when you are graphing the inverse, all you have to do is choose about 5 to 4 points, a specific and representative points of the original function, and then just switch the order of them. So if you take a look at the first one, we have a parabola, right? We have 0, 0, 1, 1, and then when it is 2, it is at 4, and when it is negative 2, it is at negative 2, and then 4. So they all now switch. So the first point is a 0, 0, or you can start from the negative side and going to the right side. So starting from this point, it was at negative 2, 4. Now it changes, right? It changes. I'm going to use the red now. It changes to 4, negative 2. So 4, let's say negative 2 somewhere here. Then the next one is at negative 1, 1, and that switches to 1, negative 1, which is right there. Now 0, 0 switches to 0, 0, there's no change. 1, 1, there's no change. And then again we have 2, 4, that changes to 4, 2. So then the rest is, we basically follow the order, right? So always follow the same order in terms of graphing. So this is our inverse function of the blue one, okay? Now next one then is, we have 1, 2, 3, 4, 5 points already I plotted for you. So all we have to do is then switch the order of each point. 0, 0 is the very far left one, so I'm going to start with that one. So 0, 0 switches to 0, 0. 1, 1 switches to 1, 1. Now 4, 2 switches to 2, 4. Now 9, 3 switches to 3, 9. So I will say that's somewhere around here, and then on. Now, therefore, our function looks like this. Okay, so that's quite simple enough. Now then the last one is not really a nice looking function. It's just a function that I drew randomly. So I'm just going to put the coordinates of this one to begin with. This one has 4. This one is 1, 2, 3, 4, 5, 6, so negative 6, negative 4, negative 2, this is 1, and this is 4, and this is 5, okay? So then all we have to do again is switching the order pairs around. So instead of having negative 6, 4, it will be 4, negative 6. So we have, this is not 4, 1, 2, 3, 4, and then negative 6. So we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So it's right there. That's the first point, okay? So I'm going to number it. So the first point, and that becomes this first point. Now, then the second point is at negative 4, 0, but that becomes 0, negative 4. So that becomes 1, 2, 3, 4 right there as the second point. Now the third point is then negative 2 comma 2. So you switch the order around, it becomes now 2 comma negative 2. So it's now right there. Then our fourth point is at 1 comma 2, so that becomes 2 comma 1. So 2 comma 1, which is right there. Then the fifth point is this one, okay? That is 3 comma negative 4, therefore that becomes 3 comma negative 4 becomes negative 3 comma, sorry, negative 4 comma 3. So 1, 2, 3, 4, negative 4 comma 3, which is right there. And then lastly, we have 1, 2, 3, 4. So 4 comma negative 1, and that becomes negative 1 comma 4. So then all we have to do is draw the lines according to the order that we took. So there we go. So this red one is the inverse of the black one because it's switched around. Okay, the y equals x. Now, hopefully you can see it. The y equals x line is actually looking like this, right? And if you look at it, this part this red part is actually a reflection of this black part, right? So hopefully you can see it. Okay, hopefully you can see it. So hopefully that was easy enough lesson. Okay, I will see you guys in class. The work, I will assign it to you in class, but I really want you to focus on those work. Okay, all right, bye guys, see you in class.